Indian space research activities were started in early of 1920s with the experiments of 𝗧𝗦𝗔𝗧. He made a few experiments with sounding the ionospheres. Later, the activities were fastened with the formation of INCOSPAR, Indian National Committee on Space Research. It was established in the year 1962 with the continuous efforts of then Prime Minister Jawaharlal Nehru and Vikram Sarabhai. Later, ISRO, Indian Space Research Organization, was established in the year 1969 in order to harness the space technology for national development. The vision of ISRO is to harness the space technology for national development. And the continuous efforts of Vikram Sarabhai and Homi Bhabha led India in a superpower in space research technology. Vikram Sarabhai is the founder of Physical Research Laboratories located at Ahmedabad, and later Homi Bhabha founded Tata Institute of Fundamental Research, which are involved in space research technology related to India. Later, few observatories were established. One of the observatory is Colaba, which is established in the year 1823. Then Uttar Pradesh State Observatory was formed in the year 1954. Then Rangapur Observatory at Usman University, Hyderabad, it was established in the year 1957. By using these kind of institutions, Earth observation and observations on magnetic field level technologies were built up, and a few activities were taken up to which help the Indian space research activities. The organization for Indian space research activities is Department of Space, which falls under the supervision of Prime Minister and Space Commission of India. Various institutions were set up in India in order to help ISRO activities in harnessing the space technology. ISRO was established in Bangalore, and the institutions which were involved in space technology of India are VSSE, Vikram Sarabhai Space Center. This center mainly focusing on rocket and space vehicles. The main function of this is focusing on rocket and space vehicles. Later, Liquid Propulsion Service Center, which is the research and development unit of ISRO. This is the research and development unit of ISRO, mainly involved in developing the propellants which were used in various launch vehicles like Polar Satellite Launch Vehicle and Geosynchronous Satellite Launch Vehicle. And Satish Dhawan Space Center, previously it was called as SHAR, Sriharikota High Altitude Ranging. Later it was named as Satish Dhawan Space Center or SDSC, located in Sriharikota. Its main function is to launch the rockets which were used to launch the satellites in their orbits. Of course, VSSC and 𝗪𝗶HC are located in Thiruvananthapuram, whereas SDSC in Sriharikota. Its main function is to launch the rockets for launching the satellites. It is the top second ranked rocket launching station in the world. First one is the Kourou rocket launching station, and another one is ISRO Propulsion Center, which is meant for testing, assembling and integrating of various technologies related to ISRO space technology harnessing. And then ISRO Satellite Center, which is meant for designing, development, fabrication and testing of various satellites which were developed indigenously in India. And then Satellite Application Center, this is established in Ahmedabad. This is also one of the research and development unit of ISRO, which is meant for accessing the data which were relayed by the satellites and taking demonstrations on applications of in areas such as telecommunications and other related informations. And National Remote Sensing Center, which is also one of the key institution of ISRO, Indian Space Research Organization. This is the key player of Earth observation as well as disaster management related issues. Another one is ISRO Inertial Systems Unit. This is also one of the R&D unit of ISRO. It involves in developing inertial systems of various vehicles, spacecrafts and satellite related activities. So this is also located in Thiruvananthapuram. The questions which were related to this area is, what are the main functions of various institutions as well as their locations are also very important. Which of the following institutions are not located in Thiruvananthapuram? The question may be like asked like this. Of course, if the options are VSSC, option B LPSC, option C IISU and option D SCSC, then the answer is Satellite Application Center. This is located in Ahmedabad, whereas the remaining three were located in Thiruvananthapuram. If the question is like, which of the following is not located in Thiruvananthapuram, then the answer is Satellite Application Center. Various launchers were developed in India in order to launch satellites for national development. The various launchers which were developed are, the first one is Satellite Launching Vehicle or SLV. The product of SLV was started in the year 1970. This is a 4-stage solid fueled rocket launcher. This project was headed by Dr. APJ Abdul Kalam, and this is intended for launching a payload of weight 40 kg into the low Earth orbit. So SLV kind of rocket launchers having the capability of launching payloads of 40 kg weight into the low Earth orbit. These are the orbits at a height of 400 to 500 kilometers from Earth surface. And we have Rohini kind of satellites which were launched by using these SLV launching vehicles. The first operation was launched in the year 10th August 1979. Of course, this launching was failed. And then E2 is the second launching of SLV kind of vehicles. On 18th July 1980, Rohini RS-1 satellite was launched by using this E2 vehicle, which is a successful launching. And D1 is another SLV launching on 31st May 1981. By using this launching vehicle, Rohini RS D1 was launched into its orbit. Of course, this also a failed version. And D2 is the fourth and the last launching of SLV vehicle. On 17th April 1983, Rohini RS D2 successfully launched in its orbit. Out of these 4 launchings, we have only E2 and D2 are the successful launchings, and E1 and D1 are the failure launchings. So question may be asked like, Rohini RS-1 satellite was launched by using SLV E1, SLV E2, SLV D1, SLV D2. The answer may be SLV E2 is the correct answer, since Rohini RS-1 was the satellite launched by SLV E2 version of a vehicle. So this is also one kind of important area in order to face the question. With the experiences that were obtained by developing and applying launching the SLV kind of vehicles, we established and designed another space vehicle called Augmented Satellite Launch Vehicle ASLV. By the continuous efforts and experiences obtained from SLV and ASLV, ISRO developed world famous launching vehicles such as PSLV, Polar Satellite Launching Vehicle, and Geostationary Satellite Launching Vehicle. With PSLV and GSLV kind of rocket launching vehicles, India achieved so many records in the space technology and stood the superpower among the other countries in the world. Augmented Satellite Launching Vehicle. The project of ASLV was started in the year 1980, which is intended for carrying 150 kgs of payload into low Earth orbits. So, ASLV is a 5-stage rocket with a solid fuel rocket launcher. So, up to 1994, we have 4 launchings were established. Here in this stretched Rohini type of satellites were launched by using ASLV rocket launchers. Stretched Rohini kind of satellites were launched by using ASLV rockets. We have 4 launchings of ASLV. Out of these 4, only one has successful and the remaining were failure launchers. The first launching takes place in 24th March 1987 for launching stretched Rohini satellite of A. Of course, this was a failure launcher. And D2 on 13th July 1988, stretched Rohini B rocket satellite was launched by using this D2 launcher. Of course, this is also a failed version. And D3 on 20th May 1992, stretched Rohini kind of satellite of C type, this got a partial failure. And the fourth one is on 4th May 1994, ASLV D4 was launched on 4th May 1994. 𝗧𝗧 C2 type satellite was launched by using this launcher. This only have succeeded in placing 𝗧𝗧 C2 satellite in its orbit. The geostationary satellites which are intended for communication and broadcasting services are having more weight, about 1000 to 3000 kilograms. Previously developed satellite launching vehicle and augmented satellite launching vehicles were not capable of carrying that much of payloads. Hence, GSLV rockets were designed and developed. The project of GSLV, Geostationary Satellite Launching Vehicle, was started in the year 1990 in order to launch telecommunication and broadcasting satellites into the geostationary orbits. So, GSLV is having 3 stages. In these 3 stages, the first stage utilizes solid fuel, which is called HTPB, and the second stage constitutes of liquid fuel of UDMH, unsymmetrical dimethyl hydrazine. This is shortly known as UDMH. So, in this second stage, ISRO uses indigenous 𝗧𝗏 engines. 𝗧𝗏 is the indigenous rocket engine which is used in the second stage of GSLV. Of course, 𝗧𝗏 engine is also used in the second stage of Polar Satellite Launching Vehicle. It is the indigenous rocket engine. And the third stage is the important stage which is used to gain more energy in order to place the telecommunication and broadcasting satellites into the geostationary orbits. The third stage is mainly known as cryogenic stage, in which cryogenic engines will be used in order to get more energy by using the fuels liquid oxygen and liquid hydrogen. Of course, these two are at their lowest temperatures. In order to gain energy from these fuels which are in their lowest temperatures, we use cryogenic engines. Previously, we depend on Russian based cryogenic engines. Now, we are our own indigenous cryogenic engines developed recently. And if we see the description of GSLV, it is a 49 meters height rocket launcher with a lift-off mass 415 tons, including the propellant weight also. So, this is intended for launching payloads of weight 5000 kgs into low Earth orbits, as well as it is also intended for launching payloads of weight 2000 kgs into the geostationary orbits. So, the weight may be vary and now we are able to launch more than 2000 kg payloads into geostationary orbits. Of course, in order to launch more than this much of weight, geosynchronous satellite launching vehicle of kind Mark 3 or GSLV Mk3 is now under development. We have various variants of GSLV rocket launchers. Of course, the first one is GSLV Mark 1A or GSLV Mk1A, which is used to launch 1500 kg payload into the geostationary orbit. The second kind is GSLV Mark 1B or GSLV Mk1B, which is intended to launch 1900 kg payload into geostationary orbit. Another one is GSLV Mk1C, and the one and only operated kind of GSLV is GSLV Mk2, in which indigenous cryogenic engine was used. This is intended to launch 2500 kg payload into geostationary satellites. And another most powerful kind of GSLV is GSLV Mk3, which is under development in order to launch more than 3000 kg weight payloads into the geostationary orbits. So, here is the list of total GSLV launching operations. Up to 8th September 2016, we have 10 GSLV launchings. Out of these 10 launchings, GSLV got only 5 successful launchings as well as 5 failured launching operations. So, up to now GSLV marked 50% of success and 50% of failures. That's why GSLV is named as naughty boy by its officials. So, the first launching of GSLV variant is D1 took place on 18th April 2001. This is of Mark 1A kind. By this GSAT-1 was launched. Of course, it got partial failure. The second operation and third operations GSLV D2 and GSLV F01 got success in launching GSAT-2 and GSAT-3 respectively, and they got success in launching these two satellites into their corresponding orbits. And the later operations of GSLV F02, F04, D3 and F06 are the failured operations, whereas the recent operations are successful operations. These are of D5, D6 and F05. Recently we launched INSAT 3DR in its orbit by using GSLV Mark II launching vehicle on 8th September 2016. There is a slight difference between the notations D and F. D means developmental operations in which the functions of rocket will be noticed, whereas F means functional operations. In these operations we just notice the mechanism of satellites but not on the rocket launcher itself. So, here we have Mark II. When will be the GSLV Mark II launching vehicle launched? This type of question may be expected because Mk2 or GSLV Mark II kind of launching vehicle was launched on 15th April 2010. So, specialized characteristics of launching vehicles may be included in the question area. Hence, Mk1A about the date and the satellite may not be asked in the questions in your examinations. The specialized characteristics will be fall within the question area. Hence, when will be the GSLV Mark II, the first rocket launched, means 15th April 2010. So, another question is, in which launching operation we use indigenous cryogenic engine, that is also Mark II on 15th April 2010. From GSLV Mark II we are using indigenous cryogenic engines. Previously we use Russian based cryogenic engines. So up to now indigenous cryogenic engines were used 4 times, first one, second one, third one and fourth one. Among these 4 we use in 3 developmental launchings. In the first functional operation we use indigenous cryogenic engine in GSLV Mk2, which was used to launch INSAT 3DR in its orbit. So the specialized characteristics of GSLV or PSLV may fall within the question area, hence we must thoroughly know about all these things. With the experiences and technological aspects of satellite launching vehicle SLV and augmented satellite launch vehicle ASLV, the PSLV was developed by using those experiences. So the project of developing PSLV was started in the year 1990 and the first launch of PSLV took place on September 20, 1993. So if we see about the description of PSLV, it is a 44 meter height launching vehicle with 4 stages in which we use solid and liquid fuels alternately. So PSLV is mainly intended to launch payloads of weight 3800 kg into low Earth orbits as well as 1750 kg payloads into Sun synchronous orbits. If we speak about Sun synchronous orbit, so consider this is the Earth and these are the poles, North Pole and South Pole. Here Sun synchronous orbits are around the North and South poles. Though, so the satellites which revolved in Sun synchronous orbits will passes through North Pole and South Pole daily. So these kind of orbits are called Sun synchronous orbits or polar Sun synchronous orbits. And this is also intended for to launch 1425 kg payloads into geostationary orbits. So if we see the fuels which were used in PSLV in various stages are, stage 1 uses solid fuel. Here HTPB, hydroxyl terminated polydibutadiene, is known as HTPB. This fuel is also used in the first stage of GSLV. Previously we saw this one also. So stage 1 uses solid type fuel, hydroxyl terminated polybutadiene, and the stage 2 uses liquid fuel, unsymmetrical dimethyl hydrogen. It is mixed with the oxidizers such as dinitrogen tetroxide. Of course N2O4 and N2O5 are frequently used oxidizers which are used to help in the burning process of unsymmetrical dimethyl hydrogen. So stage 3 uses solid fuel, same HTPB fuel. Stage 4 uses liquid fuel. Here monomethyl hydrogen or MMH, monomethyl hydrogen mixed with the oxides of nitrogen, mixed oxides of nitrogen or MON is used as oxidizer. In order to minimize the usage of these oxidizers, recently scramjet propulsion system were tested from SDSC itself. Scramjet propulsion system is used to collect the oxygen from the atmosphere itself by the rocket launching vehicle instead of carrying these oxidizers from the Earth station, which reduces the weight of the rocket launcher gradually so as to obtain more energy by the rocket launcher. And the first launcher of PSLV took place on September 20, 1993, which is the failed launching of PSLV since it is failed to reach the orbit. And the notable payloads which were operated by using polar satellite launching vehicle are Chandrayaan. This is the first lunar mission of India, and MOM or Mars Orbiter mission. This is also known as Mangalyaan, which is the first interplanetary operation or mission of India, and Astrosat is termed as the mini Hubble, which is the multiple observatory of Earth. Full space observatory of India is Astrosat, and another important payload is to design the regional navigational system of India. IRNSS is designed, Indian Regional Navigational Satellite System, which is after termed as NAVIC, that means navigation with constellation of satellites of India. So these are the important payloads of PSLV, which makes India to stand among the superpowers in the space technology of the world. So depending upon the payloads and also based on the orbits into which the satellites have to be launched, various variants of PSLVs were used up to now. So these are having of PSLV generic or PSLV general form or G, and another version is PSLV CA variant or PSLV core alone form, and the third one is PSLV XL or PSLV extended large version. So PSLV G and PSLV CA and PSLV XL variations are variants designed based on the strap-on motors of PSLV rocket. If we see, this is the main engine of PSLV. In order to get additional thrust or more thrust to the main rocket, we use 6 strap-on motors around the main engine. So main engine along with 6 strap-on motors will form the PSLV generic form of PSLV. If we remove these strap-on motors, if the payload weight is small or we need to launch the satellites into the low Earth orbits or lower orbits, these strap-on motors may be removed. If the strap-on motors were removed, the version is called PSLV core alone. Core alone in the sense the PSLV is without strap-on motors. In order to launch payloads with more weight or into the geostationary orbits or higher orbits, we use high energetic, high standard or high strength strap-on motors. Instead of using 6 normal strap-on motors, more powerful strap-on motors were used in those situations. Then the PSLV version is called XL form of PSLV. As of February 15th, 2017, this is the launch history of PSLV. Till now, PSLV generic versions were launched 12 number. Out of these 12, 10 were succeeded and 1 got failure and another one got a partial failure. Till now, PSLV CA forms were launched up to 11 number. Out of these 11 were succeeded. PSLV XL form of launchings take place in the number 17. Out of 17, we have 17 successful launches. So up to now, we have 40 launches of PSLV. So in this 40 members, we have 37 continuous programs. 37 continuous programs. Recent operation is PSLV 𝗧-37. PSLV 𝗧-37. Here C means continuous program, whereas we have 3 development programs, PSLV D1, PSLV D2, PSLV D3 are the 3 development programs. With these 37 plus 3, we have 40 PSLV launchings. Out of these 40 launchings, PSLV 𝗧-13 have not yet been launched. Hence, we have 39 launchings. Out of these 39 launchings, 1 got failed and another one partially failed. Hence, we have 37 successful launchings of PSLV. With these kind of statistics, PSLV got 97% of successful operations. Hence, it is called working horse of PSLV. And GSLV is considered as the naughty boy since it has only 50% of success rate, whereas PSLV got 97% of success rate. With its percentage rate, it is treated as a working horse of PSLV, working horse of ISRO. So, these are the recent launchings of PSLV, in which recently ISRO launched 104 satellites into their corresponding orbits, which makes India the first country in launching highest number of satellites into its orbit. Previously, the records were with Russia and USA. After India now got the first country in launching highest number of satellites into their orbits. Of course, PSLV 𝗧-37 makes this record. This is of XL type. This was launched on 15th February 2017. Among those 104 satellites, Cartosat 2D, INSAT 1A and INS 1B. Cartosat 2D, INS 1A and INS 1B are the Indian satellites, or these are considered as the Indian payloads, whereas those are FLAC 3P. These are of 88 number. So, 88 𝗏 satellites, these are considered as the nano satellites. So, another are Lemur kind of satellites, these are belongs to USA, and remaining are various countries satellites. So, these all are having number 104, which makes India world number 1 in launching highest number of satellites into orbit. And another is PSLV 𝗧-36. This is also belongs to XL version of PSLV, launched on 7th December 2016. Through this launching, Indian payload ResourceSat 2A was launched into its orbit. So, that is of IRS kind satellite, Indian Remote Sensing Satellites Constellation. ResourceSat falls under IRS kind of satellite. And another launching took place on 26th September 2016. With this, India got another specialization called it can able to launch satellites into 2 different orbits in a single launch. This is the major achievement obtained by using PSLV by ISRO. So, PSLV 𝗧-35 is of generic version or general version of PSLV, launched on 26th September 2016. In this Pratham, SCATSAT 1 are the Indian, and these are the Indian payloads, whereas remaining are the other various countries payloads. Out of this, NLS 19, ALSat 1N, PISAT, SCATSAT 1, ALSat 1B and 2B, Pathfinder 1, these are the payloads of PSLV 𝗧-35. If we consider the payloads of a particular launch, the satellites, individual satellites are considered as the payloads of a launcher. And another launching is PSLV 𝗧-34. By this, India got 20 number of satellites which were launched into their corresponding orbits. This is the third record achieved by PSLV by ISRO. This is also XL version of PSLV, took place on 22nd June 2016. So, after Russia, USA and the third place goes to India to launch 20 satellites into their corresponding orbits. Out of these 20, Cartosat 2C, 𝗧 and Satyabhama are the Indian payloads. The other payloads are LAPAN A3, BROS, SkySat and 20 FLAC 2P type 𝗏 satellites. These are belongs to USA, which are meant for observing the space. These are the nano satellites developed and utilized by USA. So, by this up to now, India is the first country or number one ranked country in launching highest number of satellites. Previously these records were with the names of Russia and USA, but now India is the top one position. So, up to now India launched various satellites for specific various purposes. So, based on those purposes, the satellites of India were classified into various types. Amongst those, one kind of satellites are Indian remote sensing satellites. So, whenever any object obtained heat and radiation from the sun, it also emits the radiation reflected into the atmosphere. So, by absorbing and analyzing these radiation from the satellites, the characteristics and nature of these objects will be analyzed. So, the system in the IRS satellites is this one. So, obtaining the radiation which were emitted by various objects on earth from the satellite itself, we can analyze the nature and behavior of those objects. So, this is the mechanism behind this IRS satellites. So, IRS services were started in India with the successful installation of 𝗧𝗦𝗔𝗧 satellite in 1979. After 𝗧𝗦-1, 𝗧𝗦-2 was successfully inserted into its orbit in 1981. So, for 2013, this IRS system completes its 25 years of service. Of course, we are still using the services of these IRS satellites still. So, the recent launches of IRS satellites are Cartosat 2D. This was launched on 15th February 2017 by the launch vehicle PSLV-C-37. And another recent IRS satellite is ResourceSat 2A. This was launched on 7th December 2016 by PSLV-C-36. And another one is SCATSat 1 on 26th September 2016 by PSLV-C-35. SARAL is another satellite in the IRS constellation. This was launched on 25th February 2013 by PSLV-C-20. Another one is RESAT 1 on 26th April 2012 by C-19, PSLV-C-19. And Megatropics is also another satellite in the IRS constellation which was launched on 12th October 2011 by PSLV-C-18. So, based on this data, we may expect match the following kind of questions. So, on one side the IRS satellite may be given, and on the other side the type of PSLV launch vehicle may be given, and we must match the satellite with the associated launching vehicle in according to that. Otherwise, through which satellite launching vehicle SCATSat 1 is launched. Of course, the option may be PSLV-C-37, PSLV-C-36, PSLV-C-35 and PSLV-C-20. The answer is PSLV-C-35. That means match the following type questions as well as knowledge based questions also expect in this area. So, this kind of preparation will help you in get a good score in your examination. And another type of Indian satellites are INSAT type satellites, which are intended for telecommunication and broadcasting kind of operations. And another one is IRNSS type satellites, Indian Regional Navigational Satellite Systems. These are having 7 in number in this in that constellation. And later we have another experimental kind of satellites such as Chandrayaan 1, Mangalyaan 1 and AstroSat, which are of their mark. We will discuss it now. Here, National Remote Sensing Center, which is located in Hyderabad, is considered as the nodal agency for obtaining IRS type of data. So, this is the nodal agency for acquiring and obtaining and processing the remote sensing data, and is able to utilize in various sectors like rural development and other issues. And the data which were obtained through IRS constellation satellites were available to the users through NRSC data center portal as well as 𝗂𝗏𝗔𝗃 portal, which is maintained and designed by the ISRO itself. So, these are the various issues about Indian remote sensing satellites. To meet the telecommunications broadcasting services of India as well as meteorological and search and rescue operations, GSAT system or INSAT system, Indian National Satellite System, was established in the year 1983. It is the largest constellation in the Asia Pacific region. Of course, Indian National Satellite System is the joint venture of Department of Space, Department of Technology and Indian Meteorological Department as well as All India Radio and Doordarshan. So, every satellite in the INSAT constellation are having the payloads like C-band, extended C-band and S-band and Ku-band. These are for meeting the requirements of telecommunication and broadband or broadcasting services. And very high resolution radiometer is also equipped with the satellite in the INSAT constellation, and charged couple device cameras, these are intended for meteorology observations and search and rescue operations. These are the various payloads of INSAT satellite constellations. Of course, we have few variations in satellite payloads as well as launching vehicle payloads. If we consider the payloads of launching vehicle, we must consider the satellites as their payloads, whereas the payloads in a satellite means the devices and equipment that are used for various purposes in the satellites are considered as their payloads. Here payloads of INSAT satellites are considered as C-band, extended C-band, S-band, Ku-band. Along with those devices, VHRR and CCD cameras are considered as the payloads of INSAT satellites. So, the services obtained from INSAT satellites and the satellites are controlled and monitored by the Master Control Facility Center at Hassan and Bhopal. Those constellations were observed and monitored and controlled by this service center, Master Control Facility Center. So, these are the recent launches of INSAT satellites. Amongst those is recent one is INSAT 3DR, which is operated through GSLV F-05 on 2016 September 26. And GSAT 15 is the another satellite in this constellation operated from Ariane 5 rocket launcher on November 11th 2015. Another one is GSAT 6. This was launched with GSLV D6 on August 27, 2015. Another one is GSAT 16 launched from Ariane 5 December 6, 2014. And another one is GSAT 10. Ariane 5 is the vehicle used to launch this GSAT 10 on September 29, 2012. So, these INSAT satellites are used to launch in the geostationary orbits in order to make its service better, which are having the revolution time as that of the earth. And we use GSLV type of launching vehicles, in order to launch these kind of satellites into their orbits. So, the main intention behind these satellites is in order to meet the telecommunication and broadcasting as well as meteorological observations and search and rescue operations to meet the needs of India. We use the services of these INSAT type of satellites. So, another categorization of Indian satellites are of Indian Regional Navigational Satellite System. Of course, around worldwide these type of constellations are considered as sat-nav systems, otherwise satellite enabled navigation system, which is known as sat-nav systems. If we see around the world, USA already developed GPS, Global Positioning System. Of course, GLONASS is in Russia, Global Navigational Satellite System, and China established two kind of navigational systems such as regional navigational system called COMPASS, whereas global navigational system called 𝗬𝗎. So, these kind of navigational systems are considered as sat-nav systems which are used to give two kinds of services such as standard positioning services, whereas restricted or encrypted mode of services. Standard position of services are intended for general purpose, and restricted and encrypted services are intended for military kind of operations. In India, we have Indian Regional Navigational Satellite System. Instead of designing a global navigational system, India designed IRNSS. This project was approved by Indian government in the year May 2006. Later it is termed as NAVIC by the Prime Minister Narendra Modi. NAVIC in the sense navigation with Indian constellation, this is termed as NAVIC, which is meant for providing two levels of services. One is standard positioning service intended for general purpose with a position accuracy of 20 meters. Later, the services were given to the military services as restricted services or encrypted services with a position accuracy of 10 meters. So, the first satellite in this constellation were launched in the year 2013. On 1st July 2013, from C-22 launch vehicle IRNSS-1A was launched into the geosynchronous orbit. Out of here we have 7 satellites in this constellation. Out of these 7, 3 satellites were positioned into the geostationary orbits, whereas another 4 satellites were positioned into the geosynchronous orbits. And another satellite in this constellation is IRNSS-1B. This was launched in the year 2014, April 4, with the launching vehicle C-24, PSLV C-24. This is also positioned in the geosynchronous orbit. IRNSS-1C launched on 16th October 2014 by PSLV C-26 into the geostationary orbit, and IRNSS-1D launched on 28th March 2015 by PSLV C-27 into the geosynchronous orbit, and IRNSS-1E launched on 20th January 2016 by PSLV C-31 into the geosynchronous orbit, whereas 1F launched on 10th March 2016 by PSLV C-32 into the geostationary orbit. And the last of the constellation is IRNSS-1G launched on 28th April 2016 by PSLV C-33. This is of course positioned in the geostationary orbit. So, from this data we can expect match the following type questions as well as directly answered questions. So, through which satellite launching vehicle IRNSS-1B was launched? So, the answer is PSLV C-24. If the options may be option A PSLV C-22, C-24, C-26 and C-27. Of course, on one side the satellite in the constellation may be given, and on the other side the dates may be given, and you are asked to match the corresponding satellite with the date of launch. like this the question may be asked. Of course, on one side the satellite in the constellation may be given, and the other side the launching vehicle may be given. You may match the data accordingly in your examination. Chandrayaan. Chandrayaan is intended for observing the moon and the atmosphere and the mineralogy which is available on the surface of the moon. This was launched on 22nd October 2008 by PSLV C-11. Of course, PSLV C-11 is the first kind of its XL version. So, the Chandrayaan inserted into the moon orbit on 8th November 2008, and the moon impact probe, which is the main payload of Chandrayaan, this is separated on 14th November 2008. Of course, due to the rising of its orbit around the moon, it got a failure on 29th August 2009, which is said to be lost its connection with the ground station of Chandrayaan. So, here Chandrayaan 1 have various payloads. So, these are the indigenous payloads or Indian payloads. Terrain mapping camera. This payload is intended for map the topography of moon completely. Another one is a hyperspectral imager. This payload is intended for completely mapping the mineralogy on the surface of the moon. Later, lunar laser ranging imager LLRI, it is used to measure the height of surface of topography. Laser and hyper X-ray gamma imager is used to identify the radioactive substances which are available on the surface of the moon. And a moon impact probe, it is used to constitute the observations of lunar surface. So, moon impact probe is another Indian payload. So, with these kind of operators or payloads, 70% of the lunar surface was mapped. 70% were mapped by using these payloads. And the reason behind the formation of moon is said to be magma ocean theory. This was disclosed from the observations of these Indian payloads. Magma ocean theory reveals that once the moon was in a molten stage, it completely having the magma in the moon. So, based on these results and analysis, Chandrayaan achieves various awards: Annual Space Award 2009 and International Cooperation Award for the year 2008, as well as Space Pioneer Award for the year 2009. These are the major achievements of Chandrayaan for the successful achievements of various operations. And Chandrayaan 2 will be said to be launched during 2017 or 2018 with the same kind of observations and the same kind of payloads. Mangalyaan is the first interplanetary operation of India. With its successful installation, India stood fourth in the world after Soviet Union, USA and European agency. So, India now become the fourth country to achieve to reach Mars. Of course, it is the first nation which got success in its first attempt also. So, on 5th November 2013, from PSLV C-35, Mangalyaan was launched and it reached the orbit of Mars on 24th September 2014. So, it has various payloads: Lyman alpha photometer, methane sensor for Mars, methane exospheric neutral composition analyzer, whereas thermal imaging infrared spectrometer and Mars color camera. These are the various payloads of Mangalyaan. So, LAP is intended for analyzing the abundance of hydrogen and deuterium by the alpha particles emission. So, methane sensor for Mars is the another payload which is intended for identifying methane and the sources of methane on the surface of Mars. And MENCA is the another payload which is used to analyze the neutral composition of particles through thermal emissions on the surface of Mars. Thermal imaging infrared spectrometer is used to thermal emission as well as to map the surface and the mapping of mineralogy on the surface of Mangalyaan. This was done by TIS, Thermal Imaging Infrared and Spectrometer. Mars color camera is used to analyze the weather components of Mars. By using these kind of payloads, India tried to analyze the atmosphere and mineralogy and the living sources which are available or not available on the surface of Mars. So, the Mangalyaan was controlled and monitored by the ISRO tracking and radar center at Bangalore, and deep space network which is established in Balalu. These two are the responsible in commanding and analyzing and controlling the Mangalyaan mission. For its achievement, Mangalyaan achieved Space Pioneer Award 2015. Another kind of satellite which belongs to India is AstroSat. This is intended for space observatory. It is the completely intended for space observation, which is also known as mini Hubble of India. So, these are the various achievements which were established by India and which may be the main question area in our examinations because we have lot of achievements which were seen in the space technology. So, in this space technology, the achievements of India in the form of launching vehicles such as SLV, satellite launching vehicle, augmented satellite launching vehicle, geostationary satellite launching vehicle, as well as polar satellite launching vehicle. Of course, the various variants of GSLV and the PSLV variants are also very important. Out of various variants, how many technology launchings were established is also important. Through that, various satellites of those kinds are also very important. The various satellites of India involved in IRS type of satellites as well as INSAT type of satellites and IRNSS satellites, these are also very important. And what are the main uses of Indian remote sensing satellites is also very important. IRS satellites are mainly intended for rural planning, rural development, urban planning, urban development and natural resources analyzing and establishment and equipped with those kind of operations, soil mapping, crops yielding. These type of data will be available through the analysis of the data which were provided by the IRS constellation of services. So, based on these aspects, we may expect the questions in our examinations. After thoroughly knowing all these things, we will get good marks in our examinations.